Well, Dr. Godes, using limiting reagents in calculations is a lot harder with real chemicals than with bikes.
Or with beads. But the key is that you need to have a plan and you need to keep track of units and stay organized. And so what I thought we'd do today for the post-class video is do another problem and demonstrate problem solving of limiting reagents. And so here we have a problem. Titanium 4 chloride, TiCl4, reacts with water to form titanium oxide, titanium 4 oxide, and hydrogen chloride. Because water is everywhere, this reaction produces a corrosive acid. Storage of TiCl4 is a ticklish situation. So if Ashley had 3.15 grams of TiCl4 and Terry had 2.1 grams of water, how many grams of HCl could they make between them? Okay, so it's a word problem. We have a bunch of chemicals up there. We have some amounts up there. So what's the first thing we have to do if we're going to do stoichiometry?
Well, the first thing we need to know is what kind of reaction is going on. So we need the chemical equation.
Okay, we need the balanced equation, right? And so titanium chloride reacts with water. And so it's telling me that the TiCl4 and the water are reactants. So the TiCl4 and water are reactants, so we write them as reactants. What are the products? It says the products are titanium 4 oxide and HCl, so I'm going to write those as products. And so now that I have the chemicals, we have to balance it. And you guys are all pros with this by now, and so I'll do it by magic. Voila. So remember, we got to keep organized. So what other information do we have?
Well, we know the amounts of TiCl4 and water that Ashley and Terry have.
Okay, so I'm going to write those up underneath the balanced equation in their appropriate place. So in stoichiometry, if I want to know reactants and products, convert between them, what do we got to do?
Get to moles.
Get to moles. And so I'm going to convert from grams to moles. What do we have to use?
Conversion factor.
Conversion factor.
So we would use the molar mass.
Yeah, we'll use the molar mass. And we can formally write out the conversion factors and do it that way. Or, at this point, you should also be comfortable converting between grams and moles just by multiplying and dividing. And so I'm just going to show it that way. Okay, so take our grams, divide by the molar mass, which for water is 18 grams per mole, and you get 0.11667 moles of H2O. I have to do that for the titanium as well. Its molar mass is 189.68 grams per mole, and we get the moles of TiCl4. And remember, we don't know which one of these is going to be the limiting reagent. We don't know which one we're going to run out of first, and so we have to do this process with both. Now, the next step is to convert from reactants to products. And again, we have to do this with both things because we don't know which one's limiting yet. To do that, we use the coefficients from the balanced equation as a conversion factor to go from reactants to products. And so I'm going to write those down. So I've written the conversion factor we need from the balanced equation. I know that I want to go to HCl, so I write the 4 HCl. I know for this one I'm starting with H2O, so I use the 2 H2O. And now the H2Os are going to cancel, and I should end up with moles of HCl. So on the bottom one, I still want to get to HCl, so I use the 4 HCl on top, but I'm starting from TiCl4, and so I use the 1 TiCl4. And again, the TiCl4 will cancel out.
Okay. But Dr. Godes, we have two products here, so how do you choose which product you want to convert to?
Well, in theory, you could do it with either one, right? It would work if you calculated for either one. But since the question asks how much HCl we're going to get at the end, it's more convenient to use the HCl.
Sure.
So we multiply through, we get 0.06644 moles of HCl, 0.2333 moles of HCl, depending on which one we started with. So how do we know which one that we have to use, which one to carry on?
Right, well, since we're looking at the product, we want what's going to produce the least amount of product because that's going to be our limiting reagent. if we run out of something, we can't produce any more product. Like if we run out of green beans, we can't make any more. Is that what you guys did in class?
Yep. Yep.
Sure. All right, so since we have here that with the waters ratio, we can get 0.2 moles-ish of hydrogen chloride, and here we can only get 0.06 moles, we can clearly see that the TiCl4 is going to be our limiting reagent.
Yeah, we're going to run out of the TiCl4 pretty quickly.
Mm-hmm.
And so we did all that work. All we do is find out that we're not going to carry it on. And we take this up to products. So the last step is converting moles of HCl up to grams of HCl. And we use our conversion factor, the molar mass of HCl, and this time we multiply. And when you multiply that through, I think you get 2.4 grams of HCl. And I check significant figures, 3 there, only 2 there, and so I'm going to have 2 in my answer.
Right, and it's good that you carried all your digits through, through all the intermediate steps, just in case.
You never want to round off until the very end.
Mm-hmm.
Thanks for watching the post-class recap of limiting reagents, and good luck.